piece of cake.
Thank you. But how come you've got the bigger cake if I'm better at maths?
Well, I made them especially to help us with enlargement. That is what we're doing today, isn't it?
Yeah.
Now, you see, I made this one twice the size of that one. This one's 6 centimetres across, and this one's 12 centimetres across. So all the sides are twice as big as that one.
Well, yeah, all the dimensions are twice as long, but it's not twice as big. It's actually 8 times bigger.
Huh?
But the thing is, if you eat all of that, I think the only thing you're going to be enlarging is your belly. So I want you to put this on and go and help Claire in her dance school sort out an enlargement issue they've got.
What about my cake?
Well, if you can tell me by the end of the programme why yours is 8 times bigger, I might let you have a little bit. So while Dave dances off in his little pink tutu, I've got a bit of a problem for you. Here, I've got a photo of Dave, but it's actually a really small photo, and I think it would be good to get an enlargement done. But how much bigger should we go? Let me have a little bit of a think. Tell you what, let's play about with some figures, but watch closely, because there are often enlargement photo questions in exams. So this would be a really good one to know. Right, so here's my photo, and it's 9 centimetres high and 7 centimetres wide. But I'd like a photo that's about this sort of high, I'd say. So what's that? That's 36 centimetres maybe? So, if my new photo is going to be 36 centimetres high, how wide is it going to be? Well, it's that type of question that you'll get in an exam. So to solve this problem, we need to first of all work out the scale factor. And we do that using the formula scale factor equals new length divided by old length. So our original photo was 9 centimetres high, and we want to make it 36 centimetres high. So 36 divided by 9 gives us 4. So our scale factor is 4. Now, to keep the photo in proportion, so Dave doesn't have a skinny face or a really fat face, we have to multiply the width by the same scale factor. So that means our new width will be the scale factor times the old width. So 4 times by 7 gives us 28. So that means our new photo will be 28 centimetres wide. Easy. So the scale factor is a really important thing to know when working with enlargement. I just hope that's what Dave will see when he arrives at the dance school.
Well done, everybody. That was great. Now, who knows why I'm here? You do? Good. Come and sit down. Come and sit down. That's it. Backwards. Good. OK. Now, the Lille School of Dance has children of all ages, shapes and sizes. And as you can see, the smallest of dancers have a very nice logo on their T-shirt. That is nice. I like that one. Now, the Teenage Company want the same design on their T-shirts. They're copying you. Obviously, teenagers are larger than the little ones here, so I need you to, first of all, work out how much larger the design needs to be to look good on the large T-shirts. In other words, the scale factor. And also, I need you to create an enlargement of the design ready for printing. Good luck. Well, who knows where the T-shirts are then? You do. Will you show me? Come on then. Oh, let's go.
You sit there and work it out.
Oh, OK, thank you, Cara. Bye. Right. Alright, so that's the small T-shirt with the small logo and the large T-shirt with no logo. So I reckon we should make this one 1, 2, 3? Yeah, about 3 times bigger. That'll look pretty good. So get the ruler, a nice bit of paper and a pencil and a rubber, and that's all I need really. So here we go. I'll measure that. Yep, okay. And then, yeah, this is easy. And,
Wheel enlarge the logo in a while, but let's look at an easier problem first, just as a bit of a reminder of how to do it. Now, so what we're going to do is enlarge this triangle by a scale factor of 2 from the centre of enlargement 1, 2. Now you can see that we've got coordinates and squares, and that makes it much easier for us to do, as we can count how far away all the vertices, that's the corners, are from the centre of enlargement. So let's look at the first vertex, this one. It's 1 to the right and 1 up. Now the scale factor's 2, so if we double this, this gives us 2 to the right and 2 up, and our new point. Look. Now the second point is 1 to the right and 1, 2, 3 up. Doubling it gives 2 right, 6 up. Now the third point is 4 to the right, yep, and 1 up. So again we need to double it, and that gives us 8 to the right and 2 up. So let's join all of these points together, and that gives us our enlarged shape or image. And you can actually check the accuracy by connecting these 3 new points back to the centre of enlargement. Each line should pass through the original vertex, which they do. Perfect. Now these lines are called ray lines and could be used to enlarge the shape with or without the squared paper. So, now we remember how to do it, we can use exactly the same technique on our lightning logo. So let's use 0, 0 as the centre of enlargement and the centre of the logo, and that makes our job a little easier. So our first point is 1 left and 1 up, and remember the scale factor is 3, so that gives us 3 left and 3 up. Our second point is 4.5 left and 3 down. The scale factor of 3, that gives us 13.5 left and 9 down. And our third point is 0 left and 9 up. So the scale factor of 3 gives us 0 left and a whopping 27 up. I think I'll let the computer finish this off. Let's have a look. Perfect. That is our new design scaled up by a factor of 3. We've done it. Let's see how Dave's getting on. So Dave, how have you done with your drawing?
Yeah, it was easy.
And how high is it?
Hang on. 27 centimetres.
Oh, that's perfect. That's 3 times the height of the original. But now what you've got to do is paint them.
Paint them?
Yeah, and it took a third of the pot to paint 9 small t-shirts. So what you've got to do is work out how much paint you'll need for 9 large t-shirts.
Well, it's a scale factor of 3 because the design's 3 times bigger, so it's 3 times a third, which is 1 pot.
Well, we'll see. There should be some paint waiting for you. Let's just see how you get on.
That's 2 done. 6 more to go. Doesn't seem right. Why am I running out of ink? I've only done 3 and a bit t-shirts.
Looks like Dave is having a little bit of a problem. He's done the enlargement, working with the scale factor of 3, which is really good. But then why wasn't 1 pot of ink, so that's 3 times as many as it took to do the small t-shirts, enough to do all the large ones? What went wrong? Well, we've got to look at what happens to the scale factor when thinking about area. Let's take a 2 by 2 square and enlarge it by a scale factor of 3, so that means that each side is now 6 squares long. So the original square had an area of 2 times 2, which is 4, but the new square has an area of 6 times 6, 36. So the scale factor for area is 36 divided by 4, which equals 9. And this is 3 squared. So we can see that the area scale factor is the length scale factor squared. So as we're enlarging the t-shirts by a scale factor of 3, in other words, all the lines are 3 times longer, that means the scale factor for area is 3 squared, which is 9. So instead of needing 3 times as much ink, Dave needed 9 times as much. And if it took a third of a pot to paint the small t-shirts, it will take a third times 9 to do the larger ones. So that's 3 pots of ink. So have you worked out why you didn't have enough ink?
No, but it's all right because we found some more ink and we painted them all.
And let me guess, you ended up using 3 pots?
Yeah, how do you know that?
Well, it's easy. The scale factor of 3 was for length, but when you're painting a much larger area. And when you go from length to area, you need to take the length scale factor and square it.
Square it?
Yeah, the new design is 3 squared bigger, so that's 9 times bigger than the original. So you're going to use 9 times as much paint. 9 times a third is 3. And because it took a third of a pot to paint the smaller t-shirts, it'll take 3 pots to paint the larger ones.
I just want my cake.
Enlargement means making something bigger or smaller by a scale factor. The scale factor is the number you multiply the original dimensions by to get the new dimensions. If you're enlarging something from a centre of enlargement, you have to work out the distance from the centre of enlargement to each point and multiply it by the scale factor to find out where your new image will be. You can use the counting squares method to help. You can find a scale factor by dividing the new size by the original size. If we know the scale factor for length, you can actually find the scale factor for area by simply squaring the length scale factor. And you can even extend this idea to volume, and that should help Dave solve his cake problem.
It's 8 times bigger because scale factor for area is squared, but for volume it's cubed. 2 cubed is 8. I've got it! Sorry girls, I've got to go. There's a huge piece of cake waiting at the back of the studio. Cheers! Cake.